Hi everyone, my name is Soumyaranjan Ghade and I'm working as a software development engineer in test. Okay, so mm recently I got one of the project where I have to test a agentic AI system, okay, which have the chatbot, which have the agents integrated, which have the RAG pipeline. Okay, so the challenge is we can't test the agentic AI system using our traditional approach, like how we used to test the API and UIs, right? Because we don't know what is happening inside the agentic AI system. Okay, so basically, it is a kind of first experience for me to know something and to explore about something and find the solution, like how we can perform testing on agentic AI systems. Okay, so let me uh, give you some ideas like how these agentic AI systems look like, what are the basic components are there, okay, and what other things we'll be going to see in our day-to-day life while working with it. Okay, so that I can explain you what I am observing and what I'm thinking and how we can proceed with the testing. So I'll be going to create a playlist in future where I'll be going to develop some automation framework to perform the testing of different aspect of agentic AI system. Okay, so first of all, what is the agentic AI system? Okay, let's talk about it. So basically in organization, right, what we can see is we'll be seeing there will be a front end, correct? Basically it will be something, a dashboard, okay, where there will be a chatbot, then user will be going to perform some query to this chatbot or do some Q&A with the chatbot, or maybe give some prompt to this chatbot, right? And user is expecting something should happen autonomously, like this might be a customer care service chatbot, this might be a airline booking chatbot, correct? But how this front end system is working, correct? So definitely this front end should have a back end, correct? Let's take in back end. So in our back end, their agents will be running, AI agents, correct, to perform some task, like we can say to, if we take an example of airline, for example, airline booking system. So this AI agent have the capability to book, search, then create ticket, correct? Then what else? We can ask update or status related to our bookings, right? So this AI agent will going to perform these actions by understanding our query, correct? Along with that, let me just write, we just discuss first thing is the agents, okay. Second thing, uh, let me make it big. Okay, so second thing is, if a user want to know some information, right, like that can be related to policy details. What can be the policy? Like user want to know the cancellation policy, user want to know about the baggage policy, user want to know about the refund policy, correct? So before, what used to happen, user will be going to search in the web page, right? For example, Indigo, user going to search in web page like what is the cancellation policy of Indigo, correct? But in this chatbot system, user can ask the same query in the chatbot, correct? And this chatbot should have the capability, or this chatbot system should have the capability to find out the right information for the query the user asked. So when the user is asking what is the cancellation policy of the uh, Indigo Airlines, it should give the information here itself, correct? Not only that, if this system is a dedicated booking management system of an airline, right? They should have some internal policy, correct? Let me write here, internal policy, which is basically needed for validation, right? Validations. How? For example, uh, user booked a ticket. Okay, this is the ticket. Then user want to cancel it. Correct. And when user want to cancel it before 18 hour of journey. Okay. So in this scenario, when the AI agents will perform some action, before doing that action, it should go through some validation, or we can say the business rules, right? And the business rule will say it, user can't cancel the ticket when there is only 18 hour left or 24 hour left for the departure, correct? So this kind of policy validation also have to integrated with this chatbot system, correct? But now the question is, where will be going to keep this policy, because policy will be text based, right? So PDF, like how we are going, how we'll be going to organize those policy. So there these agents can go and read that policy and apply the business rule, correct? So let me clear some of the things. Correct. So in this situation, who will help you? So in this system, in this particular situation, uh, there is a concept called RAG, which will help us to bring out those policy, basically the relevant policy, right? So what will be the process? Agent want to perform some action. Before performing that particular action, agent will go through a RAG process. Then agent will bring the policy related information and try to evaluate if that particular action which is he about to perform is correct or not. If the action is allowed, agent will proceed with yes, it will do it. If that particular action is not allowed, agent will not do it, right? This is just basic a high level overview of that, right? So here you can see this RAG will help us in this particular situation, correct? So let me write the point so that we can go in detail what is RAG and those things, correct? Let me clear up the things. Now let's go to the fourth one. Now question is, for example, we have developed all these components and we have successfully created our backend agent system, correct? Now how will be going to monitor this system after the development, right? So we need something to monitor the agent, their actions, what is the input, what is the output, what is the decision they are making, correct? So so that in future, if something went wrong or we are seeing unexpected output from the agent, right? So we can navigate there and we can actually see the graph or the structure or the process the agent followed to complete a particular task, correct? So it will help us to see what agents are doing. This is helpful for development as well as for the testing also, correct? So the fourth topic will be the testing, right? Testing, testing plus monitoring, testing plus monitoring, correct? So let's do one thing, let's go through each one high level components, okay? So then I will show you one of my projects where I have implemented some of the components, okay? And we'll go through one story of the agent system development and how I'll be going to do the testing of that particular system, okay? So let me clear everything. Okay, so let's continue. Okay, so basically we'll go through the high level overview of each components here. Okay, so as I'm not a developer, I'm an estate and my focus is to test the system, right? So first of all, before doing the testing, I have to understand the each component of the system. Then only I'll be able to find the right solution or the right library or the right tools how to do that. Okay, so before proceeding to the testing, a person should have the right understanding of the system, how it's happening, correct? So let's go through one by one. Now we're going to discuss the agents. Okay, so let me just through here and okay, the agents, or sometimes we are telling AI agents, or else we are telling agentic AI, correct? This is what the terms in market people are using right now, okay? So what is an agent, right? So agent is just somebody in our real world scenario who can do some work behalf of us, right? So for example, I want I am person and I want to do a flight booking, flight booking, correct? So what I used to do earlier in this scenario, I'll be going to one portal, flight portal. Let's take an example of Indigo, or let's go to an airline agency like travel agency. For example, make my trip, correct? I'll go there. Then I'll going to give some input. For example, my uh, origin, then destination, right? Then date of traveling, date of return, correct? Number of passenger, and if anything else I want like launch service or Wi-Fi, food, those things. Okay, so these are the input I'll be going to provide. Then what will happen? I will get the search result basically, right? And I will see different airlines with different fares, different price. Then I'll be going to select one airline flight, correct? Then after selecting that one, fifth, I'll be going to select class like economic class or business class, right? And other services, correct? Then 6 will be the total price overview, like how much I have to pay, correct? Then 7th, I have to do the payment. I have to do the payment, correct? Then 8th, after doing the payment, system will generate the ticket, okay, plus PNR, okay, and other documents, okay. Then 9th step, before departure I'll be going to do the check-in. Then check-in process will involve with, like, if I want to take additional baggage, right? And I have to go, we can say, I have to go through some question like I have some hazardous metal in my bag or not, kind of question, right? Then it will generate a boarding pass, okay. Then after generating the boarding pass, I'll be going to travel. Then 11, I'll reach the destination. Reach the destination, correct? So this is just a high level process of how we used to travel through the flights, correct? Now in these steps, might be user will going to perform some others. For example, in the step number 4th, right here, maybe user can ask about the suggestion, cheapest flight, for example, cheapest flight, correct? Like user don't want to spend time much and want to ask the cheapest flight. Then user may want to ask the status of the flight, correct? After doing the booking, maybe after some day, user want to know the status of the flight, uh, which contains like arrival time, departure time, right? And which terminal the flight will be going to arrive, those kind of question, those, okay. Then maybe user want to get the boarding pass right after check-in, again user want to download those things, correct? So our airline booking portal or the application are providing us this much functionality. These are not the complete, but at least this much functionality they are providing, so that we are able to do the booking and we are able to get the ticket information, flight information, okay. Then if you are planning to create an agent which will be going to not replace, we can say, which will be going to reduce the manual work done by the user, okay, with a prompt. So user will come here and user will going to ask the agent, find the best flight or the cheapest flight for me from Bangalore to Delhi in the morning or in the afternoon or in the night, right? And this agent will be going to give some results, recommendation, and user going to choose one of the option from that result. Then agent will going to ask, you give the number of passengers, enter the passenger details, or you want any additional facilities like meals, Wi-Fi, correct? Then user will confirm those details and agent will ask it to do the payment. User will do the payment, and once the payment is done, agent will going to give the ticket details. Maybe the user will get the ticket details PNR number in WhatsApp as well if it is integrated through emails as well, correct? Then after some days, if user want to know the status of its flight, basically the flight details, right, when it will be going to arrive, then user want to download the boarding pass or the ticket again, right? User don't want to navigate through the portal to the exact place to find out those information. User will be going to use the chatbot to ask for a ticket, and chatbot will provide the ticket details in the PDF format or any PNG format, and user will download from there itself. Basically, for user, the chatbot will be a ultimate place where user will going to interact with the application without wasting much time by navigating through different tabs and pages, correct? Now how will be going to achieve this thing through the agent? The question is that, right? So let me do one thing, let me clear this tabs. Okay. Okay, so how agent can do that? So basically, uh, agent is consist of three components. Okay, so let me write those three components. First is the brain. Okay, then who is the brain here? Is the LLM, correct? Now there is another components that is called tools. Okay, tools. Then there is one more component that is called prompts. Okay, now if this is just an one agent, correct? You can say if this is the agent. Okay, so agent would have definitely this much things, bare minimum components to perform some actions, correct? Now so when user is asking something, correct? So how this agent will going to do work is, this agent will be going to read the predefined system prompts. So what can be the system prompts or the prompts like which have the instruction about the workflow of the bookings, what tools need to use and when, okay? Might be some of the rules, what need to do, what no need to do, right? The output formats. So this kind of things we have to give to the LLM through the prompts, basically the instruction, right? I'll be not going to the deep on it because otherwise it will be going to be a topic on uh, designing or creating AI agent, but I'll be going to the high level overview, right? Then after understanding the prompts, LLM will want to use some of the tools, correct? So when user will ask for to do a search, right? Search. So that time the agent will be going to take help of prompts and will give that prompts to the LLM, system prompts basically, which contains the information like how to perform the search, which tools it need to use, and how the output should be structured. Okay, we'll come to the part where the output structure is a matter a lot for the rest of the application, but for now we are telling to the LLM to produce the output through one specific format, like that can be a JSON, that can be a XML, okay, anything, so that the rest of the system will going to able to work basically, okay, without any issue. Now LLM read the prompts and LLM understood like to do the search I have to call a specific tool, right? Now inside these tools, right, there will be a lot of tools, and tools is nothing but methods. Okay, so let me write there will be called search flights tool, right? And this search flight tool will be going to mm, take some parameter, for example origin, then destination, the time. Okay, uh, okay, let's keep it like this. Some of the information these tools will be going to take as an input. Okay, and it will be going to return results, or basically you can say the response in JSON format. Okay, now how this tool is able to get these results might be this tool, or we can say this can be API call, we can say post API call. Okay, and this post API call can go to another system, that can be a passenger service system, PSS. Okay, passenger service system, and this API will get the details from the passenger service system and give back to the tool. Then tool will be going to give back to the LLM here. Okay, now the question is how LLM will be able to identify what is the origin, what is the destination, what is the time, what is the date, right? So the answer is LLM have to understand those things from the user query, from here. Okay, from the user query. So when user is telling I want to book a flight from Bangalore to Delhi on 10th August on morning, so LLM have to understand that. So that is called, there is two concept here. Okay, let me write. First is the intent recognition. Okay, second thing is the entity extraction. Okay, entity extraction. So what will be the intent recognition here? So entity recognition can be to understand what user want. Correct. So in this situation, user want to search for flight for booking. Correct. That is the intent of the query, right? Then what will be the entity here in the extraction? The entity can be Bangalore, Delhi, the date 10th August, and morning, right? This will be the entity. Now the LLM should be capable enough to understand these things. Okay, then while using one of the tools which is available, it is the responsibility of LLM to pass this information. Okay, for example in tools there is a search flight tool. Second, there will be a booking tool. Okay, then there will be a search for PNR tool. Okay, now the LLM should have the capability to understand which tool it need to use first. Okay, then the second thing is what are the parameters I have to pass in the tool. Now in this scenario, LLM have to understand, it have to choose the search flight tool, and in the search flight tool it have to pass these particular parameters. Correct. So these two steps should work fine. Then only LLM will be able to call the right tool and able to pass the right information to that tool. Okay, this is the first step. The second is these tools which LLM called will going to give some response back to the LLM. Correct. Now LLM should be should have the capability to understand the response and discard the noise from the response and only consider the relevant information from that response and pass to the other system. Basically this is our system in some structured response. Okay, structured format, right? Like otherwise what will happen, the rest of the system which is expecting the data should be in a particular format will be going to fail. Okay, so that's why the LLM should be able to generate the response in a certain format which is predefined. And where it will be predefined, it will be either predefined in tools or it will be predefined in the prompts. Okay, so if someone want to go a little bit details in the tools section, right, they can see in the tools there is definitely there will be a description about the tools which will help the LLM to understand what these tools will be going to do and what will be the return and what are the parameters present and what is the data type of these parameters. Okay, so to do that you guys can go through the LangChain document of the tools to understand. Okay, now after that what response structure the LLM should adhere to while the returning can be given in the prompts. Okay, and how that can be done, that can be done with a concept called few shots prompting. Few shots prompting. Okay, so what is few shots prompting? Basically we are giving some example to the LLM. Okay, how the response should be. So if I want to give an example, I can say, right, for search tool response you have to return the response in below format. Okay, that can be something like this, like what we can say, arrays of flights details, correct, something, and inside that we can give different flights objects, correct, where we can mention the origin, then the value of origin, then destination. Okay, then the date. Okay, then the flight name, then departure time, then it can be arrival time, right, correct, like these things, some blah 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 things, but that should be returned in a structured format, correct. Why? Because if our rest of the system is using this particular JSON, right, which will be basically going to extract from the LLM response, if something went wrong with this particular response format, for example this particular information is present outside of this array, correct, so the rest of the system, basically the code, the script will be not able to understand. Even after extracting the information, they'll be not going to extract, or they will be not able to convert this particular information to a certain format, right, to process it or to store it in database or to apply some logic, correct. So that way it is very important to return the result in a correct format, right. So this is how the agents work with our system. Okay, we'll be going to give the prompt to the LLM will going to use some specific tool. Okay, then using that tool they will be going to gather the information, then again they will do the reasoning, like they will understand the information and they will going to perform another set of tools, right. Might be after searching they can ask to the user, they can prompt to the user, like you choose the flight, Okay, then after user selected the flight, maybe LLM will go with, ask about the price, so the price of that flight. Then after payment is done, it will, sorry, before payment it can do the booking, it can call this booking tools to do the booking, right? And all the states will be going to maintain in this PSS. Whatever the tool call will be going to happen, for example the booking tool will be going to book the ticket, so booking tool will going to take all those information and will going to do a API call or REST call to the PSS, passenger service system, where actually the booking will going to happen, right? So this is how one agent look like. So there might be a situation where the system will be using multiple agents. Like one agent will be specialized in one particular things. For example, like this agent LLM1, or we can say this is agent 1. This agent 1 have the specialization with conversation. Okay, conversation. Then they can build, there can be another agent. We can build another agent which have the specialization in doing the booking. Means like asking user, showing user about the offer, about different class, like to show the seat selection, then do at the end do the bookings, show the results to the user like ticket, correct? Then there can be another agent, agent 3, who is specialized in we can say check-in process. So it will going to handle all those query which is related to the check-in. So now this can be a multi-agent system, right? Correct. This can be a multi-agent system. So in this system there will be a component that is called the router, right? So let me router. So what is the responsibility of this router? Whenever the first agent, conversion agent, found something and it want to give that particular task or the delegate that task to one of the other agent which is available and who have the specialization on that one, it want to give that particular responsibility and task to the another agent. So to do that we have a router. So by taking help of that router, so the router is nothing but a program, okay, or the logical program which will decide like whom I need to give, okay. So that time agent 1 will going to give the task to the agent 2 and agent will going to perform those actions. Those are part of the booking, correct? So this thing can be more complicated, right? So this is one situation. Then let's discuss about another situation. Like our user, this end user want to cancel the ticket, okay. So if the user want to cancel the ticket and our system, the agent system, will go with the canceling ticket immediately without validating any other information, it will be a disaster. Why? Because in the real time we know in in airline, if you have booked a ticket and you want to do the cancellation before, sorry, only when 24 hours left for the flight to depart, you can't do that, right? Or if you do the cancel, you will not get the refund at all, right? I'm not sure if this is correct or not, but this is how I believe. You will not get the refund at all, right? There will be 0% refund. So like this, there are many business rules present in the airline domain, right? Related to baggage, like what will be the maximum weight I can carry, correct? So in that situation, this agentic system have to understand those rules and policy, correct? Now the question is, everything we can't provide through the prompts to the LLM, right? Every time about all those policy of the flights, right? So what can be done here is, if we can develop a system, right? If we can develop a system where the agent will be going to communicate or going to retrieve the information from that particular system before performing any action, okay? So all those constructive and destructive action should have a previous layer in which the business rule validation have to be done. For example, the destructive action can be the cancel, correct? Because you are canceling the ticket. So before canceling the ticket, the agent will going to call a specific system where it will get the information related to the cancel policy, okay? Then it will going to see the present state of the system, present state of the booking information of that particular user, and we will going to evaluate, correct, if that is allowed or not, okay? Then based on that rule, LLM will going to take the decision, like if I need to call the cancel booking, or do I need to inform the user like you are not allowed to do the cancel. The same logic will be applicable to other flows as well, right? So how that system can be made, like we can made it by using a concept called RAG, right? So now let's discuss about the RAG little bit here, okay? RAG. I'm just trying to give a high level overview. Otherwise, these all components can be a dedicated topic to discuss. So let's see here the user, and we have a agentic system here, okay? Then we want to implement the RAG. We'll see what is the RAG, and we are expecting the agentic AI system or the chatbot system will be able to retrieve the right information, okay? So that based on the right information only, the AI agent or the LLM will be able to take the right decision, correct? Now in our company, if this is our company, there are a lot of policies. If it is about travel agencies or airlines, they have a lot of policies, right? Like if it is about visa, if it is about passport, if it is about cancellation, if it is about baggage, if it is about check-in, everything they have the policy. And that all policy is not possible to feed to the LLM, if this is the our LLM, at a time, correct? Because there is some limitation called context size, right? Like that many concepts are there where LLM will be not able to actually process those amount of policies every time whenever the user is asking something or asking to do something, correct? So this particular purpose we have a RAG, retrieval augmented generation, okay? Retrieval augmented generation, let's break down that process. First is the retrieval, R for retrieval, right? Let me write retrieval. In this retrieval, we are going to retrieve the right information from the company database or company S3 bucket or company SharePoint, wherever the policy is present, okay? Let's see the high level flow. And augmentation, we have to add those information to the prompt. Then those information will be go from here to the LLM, and LLM will do the generation. So we have completed the flow. Retrieval, then here there will be the augmentation. Augment is nothing but the addition of the details. Okay, and here there will be the generation. And who will do the generation? The LLM, correct? Now the question is, if I want to search for the cancel policy, or user is asking something related to cancel, are we will be going to bring all those policies from the company wherever it is kept and going to feed to the LLM? The answer is no, right? There will be a lot of things related to the cancellation, right? Correct? Are you going to pull that one? No. But this is not possible if we go through the traditional searching, correct? So what does it mean when I'm telling it is a traditional searching? In traditional searching, what happened? We'll be going to search something in database using key value pair. This one, everyone would have knowing this thing. What? Like policy header can be cancelled, right? This will be one condition. Then what? Like date should be the latest date, so that will be going to pull out the only the latest policies, right? Then what else? If it is corporate policy or not, right? So we have to provide the filter through key and value pair, correct? This might be SQL query, okay, might be MongoDB query, this can be anything, but this is how our traditional searching system used to work. And this filter can be more complex as well to make it more efficient, right? I'm not telling this is not efficient at all, but this particular query can be more complex to bring out best possible information, right? But the search is keyword based, right? But in the current time when we have an LLM, right? LLM understands much better just than the keyword. Like when you are telling policy header should be cancel, it should only contain the cancel, right? Now might be we will pull around 10 results from the database, and out of those 10 results, correct, only 2 is relevant, which is basically related to cancel before 24 hours. Okay, something like that, cancel before 24 hours. But rest of the 8 result is irrelevant, correct? Rest 8 is irrelevant. Now what we will be going to do here, we'll be going to pull all this information, we're going to post this all the information to the LLM, right? So basically what happening, we are providing noise to the system now. Noise is nothing but just like the useless information for the LLM. So chances there the LLM will do the hallucination here, correct? LLM will hallucinate here because it have a lot of information which is no need, and it will do the reasoning by using those information, correct? So what is our responsibility here is to provide relevant information to the LLM as much as possible. Okay, so for this purpose we came across a solution that is called the vector. Okay, let me write vector dv or the vector. So instead of doing the traditional search or key value pair search, what we'll be going to do is we'll be going to convert the query, okay, related to cancel whatever the user is asking, and we'll be going to convert those things to the vector. Convert the query to the vector. So what is the vector? Vector is nothing but a numerical representation. Numerical representation, okay, of that particular query. Now we'll be going to take this numerical representation and we'll go to the vector database and we'll do the similarity search. Similarity search. Okay, so what will happen during the similarity search? All those data present in the vector database which all are semantically similar to the data or the query we have given will be going to retrieve. Okay, like vector database will be efficiently able to retrieve those policy which have this information, cancel before 24 hours, this information, right? And we'll be going to retrieve those information and we'll pass to the LLM, which is more efficient than the keyword based searching approach. Okay, but in real time what is happening is people are the architect developers are using both hybrid approach, like they will be going to use the keyword based search, along with that they will be going to perform the similarity search as well, and there will be a component which is called the re-ranker. Okay, let me write this one, re-ranker, which will be going to re-rank the search results. Okay, after doing the re-rank, it will going to filter out some of the noise and then they will be going to provide those results to the LLM. Okay, this is how it used to happen. Now this particular process is called the retrieval, where the query is converted to the vector and we did the similarity search from the vector database and we found some of the information from the vector database and we provided those information to the LLM. This is called the retrieval, correct? But the question is how we are preparing our vector database for the AI agent system, right? Definitely the question will come to mind, how we put those information into the vector database. Okay, in traditional database we used to create the tables. In tables we are putting those information. Okay, so to do that there is another concept called ingestion pipeline. Okay, there is another concept called ingestion pipeline. So this ingestion pipeline have to be done before the retrieval pipeline. So what will be the responsibility or what will be the job through this ingestion pipeline? To gather all those data. So let me write, in this step what will do, you have to gather the data. Okay, this data can be take from database, this data can be take from the S3 or GCS, this data can be taken from the SharePoint. Okay, now after gathering those data we have to convert them to the vector. Okay, and before vectorization there is another process called chunks. We have to convert them to the chunks. So there is chunking methods, different strategies are available for do the chunking. Okay, chunking is basically breaking down the huge document or the information to the smaller components, right? Then after converting it to the smaller information or the chunks, we have to convert these chunks to the vector. using some of the embedding models, right? Then after converting the vector, now we'll be going to store those vectors or the chunks, embedded chunks or the vector chunks to this vector database. And this is the ingestion pipeline. Okay. There is a lot of other things as well during the ingestion, but we are not focusing on that one, correct? But this is what the ingestion pipeline look like. So once the vector DB is ready, now our other system, basically the chatbot or the AI agent system, can do the retrieval, okay, in the real time, and they can pull out those information and go to the LLM, and LLM will include those information while doing the reasoning and give us the right answer, correct? So this process is called RAG, retrieval augmented generation. Now by using this solution, we can give the capability to our AI agent to collect the right policy immediately whenever the user asking anything to do it. And by catching those details, okay, by collecting those details from the RAG process, LLM will going to evaluate those things, okay, basically the business rule evaluation or policy evaluation, and based on that it can take the necessary steps, correct? So this can be, if you go through this particular flow, we'll be able to make a right AI agent system which will solve the business problems in the real time, okay? Now let's discuss one of the important topic here while building the AI agent system, okay, that is called monitoring, okay. So the question is, in this system we have a lot of components which all are talking to each other, correct? The LLM is not predictable at all, right? We can't determine which tool the LLM will be going to call, and what if the LLM is thinking in a different way. Instead of calling search tool, it's calling the booking tools, right? What response the tools got, then after getting the response from the tool, what all are the information the LLM extracted. So this information, if you want to see in real time, we need a framework which can log every details, correct? What's the LLM is thinking, what tool the LLM is calling, what is the response of the tool, what the LLM understood from that particular response, what are the information LLM extracted from the response, then what LLM understood from this information and took the decision, what is the next tool call, and what is the final result, basically. So to monitor or to know all these details, what is happening inside the system, we need a framework, right? So for that we have a framework called Langsmith. There are many frameworks available, okay, to do this, but I'll just take an example of Langsmith here because this is the one which one I'm using in my project, okay. So what Langsmith will do is, I'll be going to write one by one. First, it will going to track, let me just zoom it a little, keep track of chat session, first of all. Why the chat session is important? For example, you have a chatbot here, correct? This is your chatbot and you are doing, you are talking to it, okay. Let me do some picture here, okay. So you just started the conversation, so this will be one session, correct? This will be one session. Then what you did, just you just logged out from the application, and you again log in and you open and started another chart, new chart basically. So that will be another session, correct? So the framework should have the capability to store all this information as part of one session, right? Otherwise it will be very difficult to know which all are information part of which session, correct? So that's why we have to store the information in the right way. Okay, we'll come back to these details later to understand how the locksmith is doing this thing, but before that let's see what is the capability of locksmith, which will help us to monitor everything. First thing, it will keep track of chart session, then keep track of user query. Third, keep track of LLM reasoning. Fourth, keep track of LLM answer. Fifth, keep track of tool calling, which tool the LLM called. Then sixth, response of the tool call, correct? Then seventh, LLM entity extraction from the tool's response and reasoning, correct? And the final answer or next tool call. Okay, and it will be going to repeat these things, okay, in a loop unless until the task is completed. Along with that, the locksmith will keep track of TTFT, time to fast token, which is basically nothing but LLM took time to generate the first token. Okay, then 10th, total token uses which have input token. What is the input token? What is the output token? Output token plus latency. Okay, then the cost of entire tokens based on the model we are using. Okay, so locksmith will be going to keep track of all this information whenever we are telling hi, right? Then LLM will say how are you, correct? So we are keeping all those conversation, LLM's reasoning, tool calling, okay, the time the LLM took to generate the fast token, generate the complete response, and the cost of each conversation, so that we can monitor this thing and we can debug our application, and we can take the business decision as well by seeing how much cost one particular model is using. We can think of to try a different model which is less which is cheaper than the existing model, right? So those kind of decision can be taken by going through these logs or this information from the locksmith. Okay, Then okay, so while development we have to integrate this locksmith with the our framework. Okay, so whatever we are performing action or the agent is performing anything, it will be going to log in the locksmith dashboard. Okay, so now what is the next? I'll be going to show you guys one of my development project. Okay, that is nothing was just a airline booking platform, and I'll be going to see the each component there. Okay, then after that we'll be proceed to the testing of those components. Okay,